This is problem 13 of chapter 9 of Giancoli 6th edition. So the question is, how close to the edge of a certain table, and they give us the mass of this table, can someone sit, a person, and they give us the mass of this person, so that the table does not tip over. Okay, so let's write all the forces that we can think of on this table. So this is the table. We have the legs of this table. We have the length, the size of this table, 2.2 meters. The distance between the legs is 1.20 meters. And we want to put someone sitting here, and we want to know how close to the edge this person can be. So x here is our unknown, okay? All right, so let's put all the forces on this table. Well, the first one that we should never forget is the weight of the table. This is a uniform beam, let's assume, so then the weight is right here in the middle. Okay, so this is the weight of the table. Okay, the table is touching the ground. There is a normal force, and I'm going to put here the normal force, Fa and Fb. And we also now want to put a person on top of this table, so we are going to put here the weight of this person. Okay, now the crucial part of this problem is to realize that about to tip means that I'm losing contact here. Okay, this means about to tip. If it tips, then for sure we lose contact. So about to tip, this is the crucial part, means that Fa is 0. Once we realize this, then the problem becomes very simple. Okay, so about to tip means the normal force at the edge Fa is just a 0. Okay, now said that, I'm going to choose a point to be my x of rotation and write torque with respect to that. The force that I do not know is Fb, so the best place to put the x of rotation is right here, so I don't need to worry about this force. Okay, so let's write the torque with respect to this point here. And what we have? Well, the weight of the table is trying to rotate it counterclockwise according to that point. So I'm going to put here the torque is going to be that weight. The distance from that point, since this is 1.2, this distance here will be 0.6, so 0.6 meters. So trying to go counterclockwise, that's why it's positive. And now for the person, this is the unknown here that I don't know this distance from the x of rotation. I'll call it d. Okay, and this person is trying to rotate the table clockwise, so it's going to be minus the weight of that person multiplied by this d equals to 0. So from here I'm going to get d. But careful, the question of this problem is not d. The question of this problem is what is x. Okay, so to get x, what we need to do, well, this whole distance here, it's 5 meters, right? We know that because the whole table is 2.2 and this part is 1.2, so I know that this is 5 and this other side is also 5. Okay, so to find x, I'm going to write 5 meters minus the d that we found there, and this will be the answer of the problem.